All right, so welcome everyone to the OMR Architecture Meeting for October 23rd. Daryl is on vacation, so I'll be taking over the moderator duties for the meeting today. We have a single item on the agenda, which is this one mask conversion IL opcodes topic from Geeta. And Geeta's on the call, so I'm going to ask Geeta to start sharing again and take over leading the topic for us, please.
Oh, sorry, I'll show in a second.
Yeah, it's because I started the recording.
Yeah.
Now every recording starts with, oh, let me share it again.
Sorry, I'm having some problems. I don't see my window anymore. My presentation. Strange.
That's an exuberant form of stopping sharing.
Sorry, one second.
For Teams.
Sorry, one second. Like strange, I'm sort of having some troubles. 1 second. So you don't see my window? My slides? No?
Correct.
Oh, yeah, 1 second. Okay, let's start again. Wow, it's kind of weird. I keep losing my... I think it's sort of me. 1 second. Sorry about that. Share window. Oh, finally, yeah. Okay, do you see it now?
Yes.
Yes.
Great. Okay, yeah, sorry about that. So yeah, today I'll present, it's actually just two new mask related opcodes, and I'm proposing to replace them with, replace some old opcodes, remove actually old opcodes that were introduced some time ago, but I don't think really used. So to start with the background, OMR has vector and mask operations defined in this file, and operations are used to create vector mask opcodes during JIT compilation. And those opcodes have operations source type and if necessary result type encoded into them if result different from source type. So TR mask types are similar to TR vector types, but the way actual variables are created can be slightly different. For example, vector variables we usually read from arrays, right? Like say, for example, vector of floats will be read from array of floats, and lanes will be placed in expected order, but the main thing is like type will match usually. But in contrast, mask types can be read and stored from and to Boolean arrays, which is pretty, I think, common and reasonable way to present masks in the storage. So from Boolean arrays, right? So and those array elements, they represented depending on the language. For example, in Java, it would be array of like byte size array of zeros and ones. And we expect, I think it's kind of reasonable to expect if they have a Boolean array, so the lowest element will become a first mask element, and the second element from lowest address will become second lane, and so on. But then it has to be converted into internal representation based on platform. So it can be dedicated mask register, or it can be, if platform doesn't have mask register, can be vector register with lanes containing like zeros and minus ones, like with sort of like bitwise presentation. So for example, on power and Z, we can use that. So this is the background. And current opcodes, they were proposed maybe like several years ago, but I don't think they actually used, and you will see why I think we want to replace them. For example, currently we would have like S standing for short, like short to mask, I integer to mask, L to M, and so on, and other way around. And even like we have V to M. Opcodes to load, store, mask variables from to and from Boolean arrays. The idea is to load scale as a scalar first, and then convert to internal representation. Because there is no other sort of load store operations, right? So we kind of reusing scale operations for that, but it's kind of not very elegant and not very nice. So for example, if we have mask of two elements, right, stored in a Boolean array, so we need 2 bytes. So we need to load 2 bytes. So we would load it as a short, indirect load of short, and then convert it short to mask. And that operation kind of assumes it only generated its child always the result of load from Boolean array. So it will perform appropriate conversion to mask with 2 lanes, checking, well, taking like ending as an account. So disadvantage of that there's always that assumption. I don't think I can't think how it can be violated, but still it's not very nice. Sort of opcode assumes that scalar value was actually loaded. It's not like your regular scalar value, but it was loaded from Boolean array. And then we need to do that byte reordering, which with sort of we realize that it's pretty non-trivial actually. It's doable, but to create nice, efficient conversion, it's not trivial. If it's like LE, we need to reorder bytes essentially because we wanted order in memory, right? But the platform might have an opcode that just will load it properly in the first place with bypassing that scalar load. And then also they look a bit confusing, like for example, as I mentioned, right, S to M, it's actually mask of long values because it's like 2 in 128-bit vector, for example. It will be 2 lanes, so we need 2 bytes, so it's short. If it's like 4 bytes, it will be I to M, but it's like not very obvious, right? So the proposal is to introduce something better, I think, mload I from array and mstore I to array opcodes. So they will take address, they will be very similar to any like indirect load or store. So we'll take like address as the first parameter, and then like stored value of mask type for store. So similar to other indirect loads and stores, but they will involve that conversion as well. As name implies, like sort of load from array. Well, it doesn't apply conversion, but yeah, loads from array and stores to array. We can be more specific with name maybe. So why these opcodes were not introduced in the first, like earlier, basically we're concerned a bit about all these methods, like and how optimizers are going to handle these arrays, these opcodes and all these auxiliary methods in OMR IL CPP. So for example here, right, like we have a method opcode for corresponding indirect load. So we'll kind of map these opcodes one to another, right? So for mload I from array, we'll return mstore I to array, and vice versa. So there is no any confusion kind of with other opcodes like load and store. So just these two opcodes, they map into each other. And this one, I think we need to return opcode for indirect array load. For this type, will return load I from array. But maybe I need to double check how exactly it's used, but that maybe needs to be clarified. But this, I think, pretty straightforward. And we already have opcodes like mload, mstore I, or without I, but they are different, right? They are for actually internal representation. They store and load masks in their internal representations. For example, optimizer can create a temp of type mask, then it would use this opcodes. But they don't intersect, and we don't need to go from that opcode to this. They don't sort of kind of they don't map into each other. They're different set of opcodes. So for example, here we can have like mstore, like simple like mstore, an internal representation mask of like the way we usually present type, like mask 128 in 32 elements. And the child of that mstore can be that new proposed opcode, result of loading from Boolean array that includes conversion and so on. And we should alias them the same way we alias in a similar way we alias right now, like vectors from when we load them from arrays. We use array shadow symbol reference. And we would like to remove these old opcodes because they're not widely used yet or practically no use yet. And yeah, I think this too would be better. So that's the proposal. Any questions of anything on any of those pages?
I just want to be clear on something you were saying about these opcodes. So you're saying mload I and mstore existed before, right?
This existing before, and these are widely used, yeah, for temps, like for mask temps. Not much, I think, in direct ones.
Okay, and but so that comment really means this mstore mask 128. This sort of there's a bunch of opcodes like that already exist. That
yeah, with different types. Yeah, with different types. Those exist, yeah, because we do create masks. We store them into temps. Yeah.
Okay, and so essentially this is just now mirroring what you had already for direct opcodes, right? Like if I read the description here, it's also got all those same fields, mask 128 in 32, mload I, except that you're making it explicit that it's from an array. So that's otherwise, I mean, this, you're saying
Yeah.
like you could have just
Yeah, the
done
same
this to
types.
begin with. Yeah, sorry, go ahead.
Yeah, all types, we, as usual, like every vector mask opcode, it has a sort of type in it. I just didn't, any types would be present like this, like here, yeah.
Yeah, so it feels like a logical sort of or extension, right? Like just like normal loads and stores, direct loads and stores have their indirect load and store counterpart. That's kind of what's happening here. The from array bit or the from array part is because you will somehow only allow this to happen above an array shadow. Is that, or an array shadow load? Is that right?
Yeah, will be array shadow, yeah.
Sorry, can I comment on that? I believe that mask load from array mask is also do a conversion because that array is always 8-bit Boolean array, but when we load it, we change it to mask and we expand it to occupy the lane size that is specified by this array type. So there is a conversion also here.
Oh, yeah, of course, yeah.
Yes,
That's
of course.
that's a sort of, yeah, the purpose, yeah, to combine. In that way, they're slightly unusual, right? It's not just load, but also conversion, yeah.
Right, and I guess I think that's why these operations are not the usual mload I and mstore I, because I mean, although maybe it doesn't come up currently, it seems like those should be dealing with the same in-memory representation as the direct mload and mstore, whereas these are dealing with a different in-memory representation.
Yes, yeah. Load and conversion, essentially, yeah.
Okay, I think I follow. Thanks.
Yeah, like the way we have like load and conversion, but we essentially combine them because this load is inefficient load. It's existing load we reused, but then more work to convert it. So we kind of combine this two into one.
Okay.
All right, so no objections, like yeah, I think these opcodes we had some PRs, but I think with you know, they're not widely used yet, and can be converted. Actually, we'll simplify these evaluators for this. If such evaluators already exist, it will be easy to convert them.
Kita, sorry, I had one other question. So the to and from array is the structure of the array consistent across platforms, and like is it like we're defining what that array structure format looks like? It's an array of Java booleans, or
I guess we're saying any booleans, like depending on the language. Name doesn't reflect that, but it's a good point. Like basically it means Boolean array. Maybe we should say from Boolean array to Boolean array. Yeah, and a representation of that Boolean array, it can be language specific. Sort of to make that more general.
so how does a code generator implement that then? Like these are opcodes that the code generator needs to implement. So how does it know how to translate an mload I from array mask 128 in 32? How is it supposed to know what the format of a Boolean is to? I assume by a
maybe
format of Boolean, I assume we're meaning like 0 or 1/0 minus 1, like that kind of definition you're talking about.
or maybe yeah, maybe I got a bit confused. Yeah, sort of would it's we can define it as a language. It's language specific, but I think in OMR right now, OMR in general assumes sort of de facto, assumes that Boolean values are zeros and ones that are coming from a language. So current
Great.
OMR assumption, maybe it will be extended in the future, and there will be a way to check. Yeah, but currently OMR sort of de facto, we assume that it's Booleans at zeros and ones.
So on every platform, the code generator converts mload I from array mask, blah, 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 assuming that 0 is false and 1 is true.
Yes, yeah, there is that assumption, or will be.
That seems to me something that should be defined as the opcodes should be defined to be that way.
We can
Leaving that as
define, we
kind of an
can say.
unspecified thing is like, especially if everything right now is assuming it. It seems like that's just part of the semantics of these opcodes, as opposed to saying, well, it's currently 0 and 1, but it could be something else in future. That seems I would rather have different opcodes for that. If there's if there's going to be another opcode that has another interpretation of the input data, it seems saner to me to say these are the semantics of these mload I and mstore I. These are the values that they're going to use.
Okay, yeah, we can do that. Just not sure we want to make the name sort of longer, but in the documentation
I'm
in
not saying we
the
have to change the name. I'm just saying
yeah, but in
that should be the definition of
yeah
it.
.enum file where we define them. Yeah, yeah. Okay, I'll take a note. Make it explicit. Yeah, I think it's good to make it explicit. Yeah.
That's I agree with that. I think I think we're in little danger of something else coming along and deciding that 0 is true actually all the time for whole language, and you know, we can cross that bridge hopefully never, but you know, if we get to it.
Yeah, I'm not so much worried that someone's going to reverse the definitions of true and false so much as like some platforms treat true as 1 and some treat it as -1.
Right, yeah, which is very important, which can break implementation, yeah, when we do this conversions, yeah.
We could define the load in a way that accepts, like, for example, like on load, you could have a 0 non-zero distinction so that the exact value that is used for true is not relevant for loading purposes. It would still matter for store.
With simplicity, like, because we had experience, right, with all this opcodes, and if somebody it's like it makes it more difficult when you don't know whether like true is 1 or something non-zero. It makes it much more difficult
Right,
to
like if
implement. We want
if
to
we
know
can
that it's
assume
1.
right, then we can generate better code.
Yeah.
Yeah, okay, that
Much
makes sense.
easier, because you do all kind of shifting. Like what if platform doesn't have any good instruction to load it and still gonna use scalar load? Then all kind of extension happening, shifting, and so on. So better, I think, yeah, to assume
Okay, so it sounds
one
like a series of single byte 0, 1 values in memory.
sequence of zeros and ones, yeah. Okay, any other questions or sort of considerations? Like, I think, like we discussed, like, looks like optimizer can handle all of this fine.
I just want to add another advantage of these new operations over the existing opcodes, which is that the existing opcodes top out at being able to produce or deal with masks of at most 8 lanes, because that's the most number of bytes that we have in a primitive that we can convert to and from.
Actually, sorry, I realized that we do have V2M, which is kind of also looks very strange. But if it's
Oh,
like we
okay.
need 16 bytes, but again, it's kind of a bit confusing, I would say, that name. So you can use
and how
vector.
did that like just interpret the vector as, I guess, a vector of bytes, and then it was using the vector lanes, but then
Yes,
I guess it would have
yeah.
to flip which vector lanes it's using based on the endianness or something, maybe. I
Need
don't
to
know.
use yeah, it will be kind of confusing, yeah, like
Okay.
assumes, yeah, actually would be very confusing semantics, like we need to kind of make some assumption of how that vector was loaded. Yeah.
Okay. So definitely the new one seems clearer then.
Much more clear, yeah. And there are like many of them, right? There's so many opcodes, and here just two, just with different types, like following our convention, yeah, like any type like this, part of the opcode essentially. All right, so it looks like basically there's an agreement, I think, right? We can open PR and people can always like comment you know, if there, and see how it goes. Like I think it should work. The main concern was about all these methods, but looks like, as we discussed, you know, with Devin, like looks like they should work.
Sounds
right.
good.
Yeah.
All right. Thank you, Gita.
Thanks.
And since that is the last topic on our agenda, I'll poll once quickly to see if anyone has any new items that they just want to talk off the top of their heads about. Okay, I've been well trained to expect the answer no. And with that, I'm going to close the meeting. Thanks everyone for joining and enjoy the rest of your day. Bye.
Thanks. Bye.